A warm welcome to all of you. My today's presentation topic is experimental 2, that is establishment of pharmacopoeial standard for Phenytoin. So let's start it. Prerequisition of this presentation is to provide an understanding about the pharmacopoeial standard of Phenytoin. So let's move to the next slide. So our today's presentation objective is to establish pharmacopoeial standard for Phenytoin drugs. So let's do it. So once again, let's start with the experimental aim is to establish pharmacopoeial standard for phenytoin, and what are the requirements that you require to do this experiment. The glassware requirements like glass rod, measuring cylinder, heating metal, burette, pipette, Konica flask, etc. That these are required to do this experiment. So in a glassware requirement like hydrochloric acid, pyridine, phenanthrene, sodium nitrate, sodium hydroxide. These are various chemicals that you require to do this experiment. So now comes to the next, that is a theory of principle of phenytoin. So as you all know that phenytoin is a deconvergent drug. It is also known as diphenylhydantoin, or it is also called hydantoin derivative. It is a known sedative, anti-epileptic or anticonvergent drug. So in a chemical property, you can say the phenytoin is a white crystalline substance, so it look like that, a white substance. Its odor, it doesn't show any odor or smell, and fragrance, anything else. Its taste, that is a very pungent or very bitter taste, so you can say that. So in a solubility area, or we can say about the solubility, it is easily soluble in methanol, ethanol, and so it is also soluble in water slightly, and chloroform, etc. So you can write this in solubility portion. So it's when you see the chemical structure of this phenytoin, you will find one hydrocyclic moiety, and that having a two nitrogen or two amine group. Similarly, they have also two ketonic or carboxylic group, and in a similar way, they have a two aromatic group that is called diphenylhydantoin, because of that. So let's move to the next slide. Now let's discuss about the procedure. So in a procedure portion, you just have to write the molecular formula. As you know, the molecular formula having a 15 carbon and 12 hydrogen and 2 nitrogen and 2 oxygen. In a molecular weight, it has a 252.26 gram of molecular weight. In a color portion, you just have to write the color, like phenytoin having white crystalline powder, or you can write that it look like white crystalline powder. In a solubility portion, when you talk about the solubility, it is easily soluble in a polar solvent like water, ethanol, methanol, and it is practically insoluble in non-polar solvent like dichloroethane, ether. So these are the solution or example of solvent that you can write on solubility portion. When you talk about the chemical identification test, there is so many tests available for the identification of phenytoin sample. We have to discuss some of the important parameter or important chemical test or identification test that is mentioned in Indian Pharmacopoeia. So as per the Indian Pharmacopoeia, there is three standard test available in Indian Pharmacopoeia. So first one, that is in which you have to take 0.5 gram of drug in a test tube, in which you have to add 5 ml of water, and you have to acidify that test tube with the dilute hydrochloric acid. When you acidify with dilute hydrochloric acid, you will get white precipitate at the bottom of test tube. This formation indicates the presence of phenytoin solution or phenytoin compound in a drug sample. So you can also use this identification test. When you talk about next identification test, in which you have to take 1 gram of drug sample in test tube, in which you have to add 10 ml of 10% weight by volume solution of pyridine. After addition of this pyridine, you just have to add 1 ml of copper sulfate in that mixture of test tube, and allow it for standing for 10 minutes. After it's standing, you will get white blue precipitate at the bottom of test tube. This formation indicate the presence of phenytoin in a test tube or in a drug sample. So you can also use this identification test. So now let's talk about last process or last chemical test, that is a suspension of 1 gram drug sample in test tube, in which you have to add 5 ml of water, or you have to make up their volume with 100 ml of 0.1 molarity sodium hydroxide solution. When you add this sodium hydroxide solution in a 5 ml water containing phenytoin sample, you will get a clear or transparent solution at the end of this test, and this indicates the presence of phenytoin in a test sample or test drug sample, है so you can also use last one, है so now let's move to the next slide. Now comes to the next process, that is assay. As you all know, the assay is a quantitative analysis of any compound, है so in assay portion, you just have to weigh accurately 0.1 gram of phenytoin sample or suspend in 20 ml of water and 8 ml of 0.5 normality sulfuric acid, and heat it gently for at least 1 minute or 2 minutes, and after it's heating, you just have to cool down and add 30 ml of ethanol, or you can also use methanol, and titrate this solution with 0.1 molarity sodium hydroxide solution. And when you titrate by using phenytoin solution or phenytoin indicator, you will just see the pink color at the end of titration, at the end of point. And so each ml of 0.1 molarity sodium hydroxide solution is equivalent to 0.002743 gram of phenytoin. So you can also use this portion for the calculation. And another determination, another pharmacopoeial standard, that is determination of melting point. So you just have to take a capillary tube and fuse it from one side or by one vent by heating on a split burner, and fill the powder drug in it, and to up to height, and keep this tube in a melting point determination apparatus and note down the melting point. And so now comes to the next, that is the calculation portion of essay. So in a similar way, in a calculation portion, like you just do similar thing, like in you also have done same thing in titration portion or relative titration, acid base titration. So in the first column, you just have to mention a conical flask container, whatever they contain, like a 0.8 gram of sample plus 8 ml of 0.5 non-molarity sulfuric acid plus 0.1 molarity sodium hydroxide solution, and the next column, that is burette reading, whatever volume that consumed by the conical flask, you just have to write it initial volume and final volume, and the exactly consumed volume, that is a difference, so you just have to write in a last column. After writing of this table, you will have to calculate their exact percentage, so as you know that 1 ml of sodium hydroxide solution contains 0.02743 gram of phenytoin, and so similar way, x ml of or whatever amount consumed by the conical flask, you just have to multiply it with this 0.0274 gram of phenytoin. When you multiply this entire consumed volume with standard amount of phenytoin, you have to multiply it with 100, you will get the exact percentage yield or percentage purity of this sample, whatever they having an amount of phenytoin, so you just have to write their amount in a result portion. Like in the result portion, you just have to write it like pharmacopoeial standardization of an analysis of phenytoin has successfully performed, and the percentage yield and the percentage purity of phenytoin was found to be something whatever the amount you found, and the melting point is found to be. You just have to write that and on this result portion. So that's it from my side. These are the various references you can use for the further study of establishment of pharmacopoeia standard for phenytoin, like Indian Pharmacopoeia, Ashutoshkar and Manav Sundar books. So you can refer these books for the further study. And lastly, thank you very much to all of you, and I hope that you all understand the things. And thank you very much.